This is still VUC 476. It's easier than starting a new session, and it's a lot of weird management tasks that I don't really have time for. So we're going to go right to the next segment, which is YateBTS. And for that, I've been speaking to Diana and David Burgess and Paul, and we're going to turn it over to David and Paul. I'm very disappointed to see Diana's not with us, but I'm sure she's not far, and maybe she'll show herself at some point. I'm also hoping, because I'm at a loss to introduce this in a way that that is simple enough, you know, and I would love to have somebody give a good background of this, and hopefully David will be able to do it. David, you had a great video as well, and by the way, we want to tell people to go to OpenBTS.com. Also, Corrado's joining us. David, I'm going to turn it over to you, and if you could take like a 20,000 feet view and explain a little bit about some of the things that this is going to solve before we get in, because it's going to be very techy and very geeky in a moment. But before we do that, if you could get into the real basic view of who this is going to help, that would be very cool. And there's a lot of things online people can watch. So without further ado, we're going to turn it over to David Burgess, and he's going to introduce Paul, and we're going to be talking about YateBTS.
Yeah, so I'll start really with just a description of what is YateBTS, and then how would it be used, and who do we think is going to help. Start by saying that what YateBTS is, it's as close as you can get to a software-only implementation of a full, in this case, a 2.5G mobile network, and it's all software from the radio modem all the way up to the HLR, and running in a single box under Linux. And this also includes, at least in the commercial releases, includes the normal SS7 interfaces. So this can be integrated into a normal 2G or 3G mobile network using, for example, the SS7 MAPD interface for roaming. What this is, in some ways, this is kind of the way that something like Asterisk changed the PBX market. You can think of a device like the Blade RF, which we're starting to work with pretty heavily, or the old USRP that we used to work with for OpenBTS. You can think of that as a device like that as being sort of the radio equivalent of a Zaptel card. What YateBTS is useful for in the mobile operator network is to enable operators in the future to be able to run 2G and 4G radio access networks side by side on top of the same core network. The reason you would want to do this is because there are places and applications for which 2G is really a better fit than 4G. One, for example, is the MDM market, where there's a lot of 2G and 2.5G equipment installed already, and no one really wants to replace all of that because the speeds of 4G are completely unnecessary for those applications. And the other is just to maintain or extend basic rural telephone service in a lot of places. Places where installing full-blown 4G radio access networks, LTE node beads is maybe not economical and not a good use of the bandwidth. And this was actually part of the sort of dream that we had that I had at one point with OpenBTS. But the advantage of doing this with Yate is it allows us to put a much richer, fully functional IMS client in the radio access network to sort of represent a 2G endpoint in this LTE IMS space. That's the beginning of an explanation. Does that I mean, Randy, does this answer?
Yeah, I think that goes a long way towards explaining to the average person what we're talking about here. And now we can get real geeky.
Okay. Can I get geeky first?
Yeah, go, James.
Yeah, David, which radios are you using on the end now? Are you using OpenBTS or something else?
So the The radio modem part used in YateBTS is taken directly from the public distribution of OpenBTS. So, and Paul later can speak to some of the technical details of this. What we call YateBTS is actually three pieces. One is Yate itself, which again Paul can address. The other is a component called MBTS, which itself is broken into two pieces. What MBTS is basically the public release of OpenBTS that's been decapitated at the layer 2, layer 3 interface. And then there's the transceiver component, which sits sort of under MBTS. It's sort of the lower piece of MBTS is the transceiver component. That's also taken directly from the public distribution of OpenBTS, so it supports whatever radios OpenBTS supports. Right now, that's a wide range of products from Edis Research. It's the Range Networks RAD1 radio, which is in the process of being released publicly. And it's also very soon the Nuand Blade RF, which is a very inexpensive software-defined radio platform. OpenBTS support for the Nuand Blade RF has been working on the bench for about 2 weeks now, but hasn't been released publicly yet, but it will be released publicly soon. And as soon as that's released publicly, then YateBTS will be working with the Nuand Blade RF. We're putting together a development kit for YateBTS that will be based on the Blade RF board.
Great. That was a very comprehensive answer.
Right.
What about, oh, hello, Diana. How pleasant to see you.
Hello, James.
you're
Nice to
muted.
see you as
Oh.
well.
I'm looking forward to seeing you in Barcelona, by the way. We must do lunch again.
Absolutely.
I'm also interested to know about support for 3G and LTE. The OpenBTS stuff always used to support the 2G services. Where are you with 3G and LTE right now?
So James, let me ask you this. Do you know anyone who is planning to have 3G in the next 2 years? Because 3G is like so dead in the baseband processors. So why bother?
I know of at least one operator very, very close to here who is deploying 3G right now. So, yeah, is the answer. That was a very loaded question, Miss Diana.
And
As far as our support for 3G and 4G, I'll say this. Our company that we have set up in Bucharest now to do radio access networks is called Legba SRL, and its American sister company, Legba Incorporated. Our main mission for 2014 is to do an LTE Node B stack and at least release a useful functional subset of it publicly under a GPL license. In fact, if you look behind me, you can see we're actually in our conference room here at Legba, and that's our network diagram. If you look real closely, you can see the Legba logos on the eNode B units at the tower. And that project's coming along nicely, and we expect to have GPL releases of parts of that by mid-year. So
this is exciting stuff, David, because nobody else has before been brave enough to take on head-on anything as complex as this outside of the big players.
Well, 4G is actually not that bad. I mean, I don't mean to disparage the technology, but an eNode B is basically a glorified Wi-Fi node. I mean, it's a Wi-Fi node with quality of service guarantees.
Yeah, absolutely. Well, the authentication is much more complicated.
True. It has much better security than a Wi-Fi node too. As far as 3G, we're not going to do it. We have no plan to do 3G, and the reasons we don't: first, 4G is growing much faster than 3G, so by the time we get to market, we think 4G is probably going to dominant sales are going to be in 4G. I'm of the opinion that 3G is going to come and go, and that in the future we're going to see a future for a period maybe 10 years after that of mixed 2G 4G networks, and 3G just sort of going away or becoming a stagnant.
Yeah, I think you're probably right there. I think the future is in LTE, and for a number of reasons, like it's spectrally more efficient. And but today there are many more 3G capable devices than there are LTE devices, which is one reason why people deploying low power infrastructure today quite like 3G because there's a lot of 3G out there.
I'd also say this: as a small company, 3G is not something we have any interest in touching. I mean, the problem with 3G is that
I understand that totally. And you know what, David, I think you're doing the right thing.
Okay. Well, thanks. I mean, honestly, UMTS is a grotesquely over-engineered technology. It is no, honestly, the UMTS specifications are 10,000 pages of intellectual masturbation.
You've been listening to Diana again, haven't you?
No, really.
That's one of Diana's lines.
So, David, this is Carl Fife in Chicago. I'd like to know why you think that the 2.5G, 2G technology is going to be so durable. Why it has been so durable?
Because it is beautifully well adapted to do two things. One is to deliver telephone calls, and the other is to deliver medium rate data over very large distances with really cheap equipment and good power efficiency. That's why.
I see. And is it? I mean, is it that kind of plus the fact that there's so much incumbent hardware, or is it more solely that?
Well, no. I mean, if GSM were a new technology, no one would have any use for it. But the fact that there is so much incumbent hardware that is so good at doing what it does, you know, I think there's a motivation to keep it. The main problem with keeping 2G is, as we move forward to LTE, the main problem with keeping 2G is that carriers are going to have to start putting up IMS core networks to support LTE, and that creates a problem of having to manage, you know, yet another core network if they want to keep their old SS7 networks around.
Right.
You know, in some ways, I think IMS and LTE are a tremendous threat to affordable rural telephone service, but that's an entirely different sort of political and social topic.
Right. So another way of summarizing it in some sense would be like, 2G solves has sort of one killer app, which is voice. 3G has none. It kind of sucks at voice and it sucks at data. So 4G at least has one killer app, and probably good enough to kill the first out of the 2.5G stuff.
What do you, when you say 2G, you're talking edge?
No.
Well, TDM, GSM.
Which is what? Data-wise, it would be
TDM.
Well, I don't know what that.
Time division multiplex.
Yeah, I know what that means, but I don't know what it means.
It means 2G just means GSM. It means a network whose primary application is circuit switch speech and text messaging on the side.
Okay, where does Edge fit? I mean, because I'm very familiar with Edge when you run on 3G.
Edge is what people refer to as sort of 2.5G, isn't it?
Okay,
yeah,
that's what I wanted to know.
Yeah, Edge is basically GPRS with a little faster modem.
Yeah.
So just
wait a minute. GPRS was like 128K or something.
Yeah, but Edge and GPRS are, from a network standpoint, they're the same technology. The only difference is the radio modem.
Okay. And Diana's making a peace sign, so she wants to say.
It allows you to use more time slots to go faster with data. That's all it is.
Diana.
Hello, Diana.
So,
she wants peace. Go ahead.
And to say something, actually, not peace, but fine. I want peace as well. I will say this. The fastest growing market in the mobile network business is actually the M2M applications. And nobody is going to install an LTE modem into an M2M. So obviously it's going to be 2G. It's that simple.
And that, I mean, honestly, I was looking.
Lots of people would not agree with that.
No, really. I was looking for an embedded 4G modem. I was looking for a 4G modem for an embedded application, and all I could find were 2G and 3G.
It's too early yet. That's why.
Yeah, but even when they do have LTE modules, they're still going to be cost prohibitive to put into a sort of mass market M2M device.
Well, thank you guys.
Yeah.
That's it? Is that all you got?
Come on, you can do better than that, Diana.
Diana.
Come on.
Where's
You're
that
mellowing
feisty...
in your old age, aren't you? That's
Where's that
it is.
feisty woman that I met at AmuCon in 19... ... It wasn't 19. It was not that long ago. But anyway. All right, where do we go from here, guys?
Yeah, can I ask, are you going to be demonstrating anything at Mobile World Congress? Are we going to be able to see some of your stuff at all?
Yes.
David?
Yes. We'll bring a kit with us. We'll bring a kit to Barcelona. In fact, we'll bring a kit with an actual. We'll bring a kit that does an actual SS7 map interface to a production HLR.
Now I'm getting excited. So should I bring in my? Should I bring a baby HLR in my suitcase with me?
Raise that camera up just a little bit, James, if you're getting excited.
You have to ask. I'll leave that one to Diana and Paul, since they deal with the core network end of this stuff. I'm just a radio guy.
I think you're slightly more than just a radio guy, David. Actually, get on. Anyway, no, it's all exciting stuff, and once again, both David, Diana, and Paul, you are to be congratulated in the kind of work you're doing, because it's very brave, and there will be lots of people in big network infrastructure companies looking at what you're doing and saying, "Oh no!" So keep going. It's very, very exciting stuff.
Well, thanks. And I know there was a question I saw in here about. Oh, never mind. Never mind. I misread something. Never mind. Thank you.
Yeah, there's actually Carl's asking something, and maybe he can elaborate via audio.
Yeah, I was just curious whether you're saying you can only find 2 and 3G radios, and I was wondering if you think that the lack of a 4G radio is a matter of IP intellectual property encumbrances, or is it just a matter of it being such a specialized piece of hardware, such a specialized ASIC that it's just it just hasn't made its way to the commodity market yet.
So, just to answer to that question, even if it wasn't addressed to me, I will say this: GPRS modem uses far less power than an LTE modem. And if you think about this, a lot of these embedded applications actually depend on power, which is not always. They cannot be connected to the power grid, especially things like agricultural sensors, parking meters, a lot of really non-standard applications, whatever will be called the Internet of Things. And because our culture tends to need a lot of those applications where we cannot actually install the power grid, I think the 2G is the only one that will actually be available for quite a while.
Yeah, I agree. I think that's a very good point. I think 4G, the cost of 4G user equipment, the cost of the chipsets for 4G user equipment will come down. I don't think it's intellectual property encumbrance, really. I think it's just a new, it's a new product. The price will come down, but the power consumption is not going to change a whole lot. And for a lot of embedded applications, power consumption is a very big deal. And this is one of the reasons. Again, this is one of the reasons I think that for certain applications, there are a lot of customers out there who would prefer to use 2G or 2.5G networks as long as they possibly can. Power consumption is a very important consideration for a lot of these applications. It's also an important consideration for telecom service in the developing world, but that's another question.
Absolutely. What about the white space stuff that uses protocols like weightless? Because potentially they are going to be very, very low cost, and they're going to be very low power consumption as well. What sort of impact do you think they're going to make on the M2M type market?
It's a good question. I don't have a good answer. I think what I'm interested to see happen in the white space market, because it's an unlicensed spectrum market. I'm really curious to see how that plays out. Because if you look at mobile operators today.
Yeah, sorry, that's why it's so exciting, because the big MNOs don't have a stranglehold on the spectrum. Therefore, one of the big barriers to usage is just not there, so anybody can use it. So that's why it's really exciting.
I think anybody can use it, but there's also the question of what applications, because anybody can use it, and because there aren't big mobile operators putting huge budgets behind it, I'm curious to see what applications emerge also. I mean, what white space devices exist right now? How long has white space spectrum been open in Britain so far, and what devices are actually available?
It's about last year, and the first tranche of devices are becoming available now, coming out of Cambridge in UK. The chipsets are certainly out for embedded devices. So I think give it about another year, and we'll start to see very low cost, very low power white space devices becoming reasonably widespread. So they're being used. They were used, a year and a half ago in trials in UK. Trials were very successful. And Newell is one of the teams to watch going forward, I think. I'll tell you what, let's all go and see them together in Barcelona, David. We'll go together, shall we?
Sure, but I don't think that's going to change the fact that 10 years from now, LTE is probably going to be the dominant broadband technology in the world, and that 2G GSM is probably still going to be around.
Yeah, and I think we'll probably see composites as well, where you use LTE for a central node to do the backhaul, and then white space to do the medium range link to multiple low power devices. So typically, you could have one LTE device in a village, which then serves something like 200 white space devices, possibly something like that. So they're not mutually exclusive technologies. I think they can work together.
It's kind of one of the reasons I decided to run out and buy an LTE capable phone. By the way, Rule has a question. Rule, if you've unmuted yourself, please go ahead. He'll be here any second. *6 to unmute. I think he's in ZipDX, right, Rule? I know he's a tram. Who's the Pavlov among us? No, we can't hear you, Rule. Why can't we hear him? Let me see if he's talking to ZipDX. Oh, wait a minute. We're not getting ZipDX anymore, apparently, because he is speaking.
Hang on. Can you hear me now? There was a change there.
Yeah,
you should be able to hear us now.
Okay, Rule, go ahead.
Okay. Okay. Can you hear me now?
We got you.
Yep.
Okay, good. Yeah, it was actually just a question about y'all mentioning white space. And what exactly do you mean by that? Is it unlicensed spectrum or spectrum that's just
now we can hear you, but I'm getting horrible packet loss. I don't know about anybody else.
Yeah.
Yeah?
Yes, the question is about the definition of white space. What exactly is meant by that? Is it just unlicensed, or is it something other?
Guys, I'm sorry. I just want to say something. Can I?
Sure.
Go ahead.
White spaces, it's a broad issue because you don't have devices. So I just think that it was not much of a thinking until someone actually does it.
The other thing I'm going to say about white space, one of the reasons we have big, large, like nationwide, continental-sized mobile operator networks is because radio spectrum licensing gives mobile operators a partial monopoly over the spectrum. And that gives them a motivation to build and invest in huge networks and actually build these things. In the white space world, if anybody can go in, what's the motivation to build large networks? I mean, if anybody, it's like running ISPs. Now, that's a whole other topic of, is LTE just going to turn mobile operators into giant ISPs and licensed spectrum, which it probably will. But what's the point of having a giant ISP in unlicensed spectrum? If any can jump in and build another network, what's the point? Why invest? Why have these huge investments? I mean, the only thing that mobile operators have anymore that's worth anything, they have their brands and they have their spectrum and they have phone numbers. Even phone numbers may not mean anything a few years from now. These are the only assets they have anymore.
Yeah, I don't think phone numbers are a big deal. Go ahead. I'm sorry, Diana. Go.
I will say that even if the phone numbers are not a big deal, the spectrum is a big deal. There is an entire regulation around that, and like I've said, there is no point in actually going and talking about that when it actually makes more sense to talk about things that we know for sure they're going to be here. And for example, I had this really wonderful meeting one day with a taxi driver, with a cab driver in Bucharest, if you can imagine this. And this guy was probably making about, I don't know, $400 a month. That was probably as much as he was making. And at some point, he had this tablet on his machine. And for some odd reason, can you hear me?
Yes, absolutely. Go.
And at some point, he played on the tablet something like Julio Iglesias, and we complained that is not the best song or whatever, and he started to browse on YouTube and played a different video. To which point I was like, what the heck is going on? And I asked the guy, what's your mobile data plan? And he was like, well, I'm paying about $30, which was probably about a bit less, about 8% of his monthly income for internet access on my tablet, because I'm having a 20 gigabit of 20 gigabit of data plan. So no matter if we like it or not, people will actually want to have a lot of data. And here's the thing, if people want to have a lot of data, the spectrum has to be refactored, no matter what we believe. And if spectrum has to be refactored, everyone is going to go to LTE. It's that simple. And once people are going to go to LTE because everyone wants data, the next thing is going to happen is that they will have to solve the voice over LTE issue, which puts me in a nice position because I have a voice over LTE solution. Yay. And on top of that, they will not want to maintain a core network for SS7. And once enough carriers decide to have roaming on a VoLTE and not support the SS7 network, in a year it's going to be shut down. Because the only reason why the SS7 network exists is because everyone is using it. Does it make any sense?
Yes.
A couple of questions on IRC. First of all, Rule was what he was trying to say is, he says, I was just wanting clarification on the definition of white space as you were using it. Does that mean fully unlicensed, like the ISM bands 900, 2.4 gig, 5.4 gigahertz, or just unsold to specific carriers? And I have another question after that. So clarification on the white space, David or Diana?
I think I can answer that
or
if I don't drop out. Yeah, white space uses spectrum, which is normally primarily allocated to another user, and the majority of the white space spectrum in use at the moment is used by broadcast digital TV. But because TV uses big, powerful transmitters, they have to be spread out widely. So what that means is if you do a scan of the...
Oops. Am I still here? Okay, well, James dropped out. While we're waiting for James, let me get to the other question, which was posed by Alex Kinch, who's not in at all. He's just watching, and he says, He says, I've seen the dev kit, but wondered if is YateBTS available in software only so we can use our own radio hardware, and if so, what radio hardware is recommended? I'm going to guess that's for you, David.
It's short answer, any hardware that worked with OpenBTS will work with YateBTS, and it's publicly available now. If you go to yatebts.com, you can download the source code now.
I see that Diana. Thank you, Diana. You answered it in IRC, and I didn't see that until just now. Carl Fife, James. Oh, the Bodhi uplink is lost. James, you back with us?
So I will say something about the lab kit, and maybe I should mention why we've made it.
Sure.
Well, first of all, we've made it because it's cool. Second of all, we've made it because we believe that you should not spend like 3 weeks of your life to actually put things together. Like one of the small pieces that we added in the lab kit, it's actually just a small filter, because we've noticed that a lot of people, even if they have like a new SRP radio, they have all kind of small problems to get things going. If you can get things going by yourself, good for you. But we just made it to make people's life nicer. Also, within YateBTS, we added a very nice feature called Elisa. Do you guys remember Elisa?
Yeah.
No.
I mean, that Elisa from 1962. The
computer
chatbot.
thing that talked to you, you mean?
Yes.
Yeah.
We added that, so you can actually send SMSs to Elisa, and Elisa is going to answer you back. It's going to be like your very own mobile network with your very own Siri.
Can I phone it as well? Does it do text-to-speech?
We will allow you to implement that part. And if you send us a patch, we will include it in the public version of YateBTS.
Okay. I guess it's my duty to see if anybody else has questions or whether you guys want to continue. This, I've got to say, this is really why we exist. Yeah, we show projects by Logitech and, you know, Polycom and a lot of things, but the main thrust of the VUC is for the people who are regulars here to talk to folks like you. And David, you've been on many times. Diana also. Paul, I don't know if we've actually seen you that much, but we've heard about you. And this is what we're here for, guys. So we take the time we need to, and since my wife is going to be very late, we have hours in front of us if we need it.
It's something, and while we're talking about the lab kit and stuff, we spent a lot of time talking about radios and spectrum and all that. But one of the things I think, like Paul, to talk for a little bit about the sort of network in a box function. When you buy the lab kit, what it is basically a complete 2G network in a box with all the functional components.
One of the things that was exciting for a long time was to have an entire network. So that was an idea that haunted us since long. So we implemented parts of it, the public interface, and also try to do with the hardware available. We do a better solution. So we used whatever we knew best, that is Yate, written by us. So we built YateBTS, this piece of code that adds all the GSM functionality to Yate. And we also implemented this network in a box, which is just a bunch of scripts, which are in the release of the YateBTS, can be installed from there. And we are going to develop it, and it will be a very small solution for experimenting and seeing how it works, and having a small network that does voice call, SMS, things like that, just locally, just without connecting to an outside network. So this all is written as JavaScript. We just like Elisa, which is integrated in the current version of NIB. So we have everything there and can be scripted further, and features can be added, whatever. As we also develop YateBTS and new functionality becomes available, scripting will make good use of it, and we can add extra features and supplementary services, conference, things like this. Actually, the phones have an interface for doing a conference, but we didn't have the way of catching that and handling it. So now we will be eventually able to do that. That's one of the reasons we have written YateBTS in the first time, because we wanted to add some new functionality which was available at GSM level. So we just made some changes to OpenBTS to be able to handle it. Then we did even more changes, and then we get some help after we talked with David and got some help making things better. So it was quite a very fast development, because from the moment we started to develop for YateBTS and until the release, it was just a little over 2 months. That's all. So it was fast, and it's very easy to add more features right now, and it will be even faster. Mm-hmm. Of course, having the network in a box is very funny, but the main idea was to provide some solution that can maintain 2G networks in a world where most of the people will migrate to packet cores and to IMS voice solutions. This provides YateBTS can become a full IMS client with all the features required, also with authentication, because we have access to the GSM layer, and can continue to provide 2G services in a mainly 4G network. And also because, as you know, we have the OpenVolt product that can interface to a legacy SS7 network for those networks that will continue to use it.
I know I'm showing my age here, but I have a question, a very simple question about white space. Wasn't white space used like 1,000 years ago for storecasting? Didn't they put some kind of an FM? No, I'm thinking of subcarrier. White space was used like in the 60s. It's not a new concept. It was used years ago for all kinds of stuff, right? I know what I just said, the subcarrier thing, that was FM. I know that, but wasn't white space used like forever for other totally unrelated to broadcast services?
Are you talking about the data that's sent in the
yeah?
In
that's
the
not that.
time that it takes for the thing.
Yeah,
no,
the
that's
scan.
Not
no, that's not white space. What's the name of that? Does anybody remember? Not white space.
I bet Jerry knows.
It's yeah, that's the data in the part of the video frame that's not seen. I used to know the terms for this stuff. Believe me.
Teletext, you mean?
The what?
Teletext.
No, this was on a broadcast. Who broadcast TV anymore? But on broadcast TV, there was the horizontal refresh interval comes to mind. I think it was called, and there was a space, a little data. You could see it if your TV set was misaligned. You could see that stuff. But the question was dumb because I'm confusing it with a couple other things. That was used to send some kind of data, and I don't know what for. But that's not what we're talking about. We're talking about white space that is frequency related and not stuck into a vestigial sideband, if I may say, use the term.
Okay.
Okay.
Can I ask? Go back to David again. David, who is going to buy? Who are you going to sell YateBTS to?
Good question.
What do you mean?
Can I, since I'm the salesperson?
Yeah.
Yes, go on.
So
go on, Diana.
We actually the YateBTS lab kit is designed for for the M2M application developers, to universities, to carriers that want to figure out which kind of problems they have in their network. We'll probably develop that to be a much more test equipment. And we actually gonna release larger boxes based on YateBTS. We did manage to solve some, by design, some technical issues that we had in the past. So one of the things that's going to happen is that we intend to build full-blown 2G networks, but 2.5G networks. And we're also going to have roaming for voice and for data for those larger boxes. We're gonna release quite soon a YateBTS open field, which is gonna be probably a 2 or 3 watt base station. Like I've said, we're gonna release even bigger power products. And we actually gonna do that because we always had a huge interest in providing the cheapest possible mobile network in the world. So we can actually touch the 2 billion people out there that do not have any kind of a coverage. And if you take the YateBTS, which is an IP pure based solution, which you can send it over satellite, and instead of SIP, because Yate has IX, we can actually use the load bandwidth. And when I say load bandwidth, I mean like 60% less bandwidth than SIP, which is way lower than the traditional SS7 solution anyway. And when I say that, I'm talking about areas where they didn't even saw a mobile network, like in the middle of the desert, because you just get a YateBTS based base station. You just drop it there with a satellite, and you just get coverage with a solar panel. There is no need for a grid. There is no need for any type of other connection. You can just do it over satellite. I'm talking about oil platforms, cruise ships, a bunch of other markets which are out there and they never got covered.
Yachts. Yeah.
Do you have
you
such
know what,
a thing?
Diana? Personally, no.
Then
we know
let's
a
keep
man
that.
who does. But
it's going to need
anyway.
one the way the rain is around here today.
Yeah, absolutely. If you know somebody with a yacht, send it my way.
Carl says that YateBTS is like wireless asterisk, in the sense that it's like middleware connecting disparate technologies. That's an interesting point, actually.
Because
you guys might not like it, but it's clever.
I mean, asterisk is a it's exactly that, in the sense that even though asterisk is, by some opinions, a sort of a train wreck of implementations and back end, it was revolutionary in the sense that it was like C3PO, right? It was like the
Swiss Army
the droid, right? Yeah, because he could speak any protocol. He could speak English to R2D2 language, or English to the binary language of
Carl,
moisture evaporators.
Please,
All right.
do not call my
the
beloved
party's over,
Yate
ladies and gentlemen.
No, but you understand what I'm saying, right? It fills the same role in the wireless space.
I think what he's trying to say is that YateBTS is like Yate for the cloud.
Don't go. Don't leave us.
I have a question for you.
Go.
So this is actually from Andy rather than me, but he's not on anymore, so I'll ask
You
it
can
for
get
him.
back on, by the way. There's room. Tell him.
If I had a bunch of existing radios, like IP access or ubiquitous femtocells, could I get them to work with this?
No. The problem with getting those to work with this is that they've got so much stuff hard-coded and hardwired into them that's just getting in your way. YateBTS just wants to work with a naked radio. And those aren't really
naked radio.
Yeah, when I say a naked radio, I mean something like a USRP or Blade RF, or another thing we're actually working on right now is a CPRI card that'll let us use remote radio heads. I don't know.
Yeah, I can see how exciting that is, because as soon as you go to a naked radio, the cost goes right down, doesn't it?
That, and also I think one of the mistakes I think that I made early on was the idea of trying to build hardware. And if we go with the CPRI cards, if all we do is make a CPRI card, we can work with radio heads from existing vendors. And what's nice about those radio heads is, you know, they're already engineered, they're already regulatory certified. For large networks, I think the radio head is a great answer. And if we just have a CPRI card, then we just use commodity radio heads. There are at least a dozen radio head vendors out there right now. Just a matter of finding the decent one. I'm sure there are plenty.
I will say this. Can we guys get back to the YateBTS?
Well, I think we better straight away.
Because I'm just saying.
Talk about YateBTS, because that is exciting as well. The fact that you're using X protocol in there just warms the cockles of my heart. I think that's great.
Absolutely, it's a great idea. It's an absolutely great idea. Just think about it. You get a GSM base station, which, let's say, it handles like 7 phone calls. Okay. Paul there, he should probably explain more about the technical details. He wrote this really wonderful modification of Yate, which does a very interesting things. It sends SIP registration requests to the Yate VoIP, which behaves as an MSE VLR, which as a URI has something like IX, does. Am I right, Paul?
Yeah, actually, we use to register over SIP on IX URI, so that we can send the calls using IX trunking, so we can get rid of some of the bandwidth when we have multiple calls. The trunking allows us to cut into the overhead for the bandwidth, so we can even use satellite or things like that, because at 5 or 6 or 7 calls already the overhead is small, while on RTP you have a pretty constant overhead, which is quite large. It can be much higher than the overhead is much higher than the data, especially when you have pretty compressed data. You have a very large overhead and a very small packet of data, and you have that many such packets, while in IX the data for multiple voice channel is aggregated, so we can have a better bandwidth. This is important. Also about the question with IP access and things like that. For those even in standby, idling with no mobile station attached, they had something like 40 kilobit per second idle traffic, because all the radio management and all the traffic still goes there, even if doing nothing. They use some protocol called A over IP, and they just exchange packets all the time about the state of the radio. In YateBTS, we confined all that into the MBTS component, which deals with the radio resource management, so it does everything inside. Doesn't even reach the other part of YateBTS called IBTS, which is the channel. Only when a call comes in, IBTS is just a channel for Yate, and it sends the call in the normal routing engine of Yate. We can send it over SIP or IX or whatever. Just like that, the registration is just a registration. We handle it uniformly, just if it came over SIP, and we can handle it locally, like in the network in a box. We can adjust it a little and send it to an IMS server, or we can just do a regular SIP registration. Doesn't even have to forward the authentication. Everything is possible. Everything is possible, because we have access at the right level, and we can play with the data as we need it. That's why we can do a lot of application based on YateBTS, integrate in an IMS network, in a simpler SIP network, or in a SS7 network, or work standalone. All those are possible.
I'm hearing some silence here, so
Oh, sorry.
I feel obliged.
I was looking at a book drinking game, which is unusual.
Well, there isn't really a drinking game because we've all been drinking for the last 4 hours. So,
Diana, can you tell us a little bit about OpenSAE, which is SS7ware's proposal for the LTE core network?
Great question.
That is exciting stuff. Tell us about OpenSAE. Or OpenSAE.
It's actually kind of funny because I initially was thinking that it's going to OpenSAE, by the way, just to solve that. But I was initially thinking that it's going to be just an LTE core network.
Super user type passwords.
Carl needs to mute.
Somebody was Carl. Yeah. Go ahead.
And what happened is that we got this MME. So Paul actually started
I remember. Yes, that's perfect. Yeah, I was saying super user, but it's medical. What's the other password? Yeah, that's perfect. Thanks, Chris.
Please tell us the password. Please tell us the password.
Okay.
What's the password,
Carl?
I
think I got him. Go ahead.
No, let him tell us.
No, he's muted.
So it started with
it's 1, 2, 3, 4, 5, 6. That's the password.
Oh, that's the same as my password. I'm gonna have to change it now.
I think it's more Deb's password for the Breaking Bad fans, since we've already broken these things up. Breaking Bad fans, Deb's password.
Now, come on. I want to hear what Diana has to say.
Okay.
So come on.
All right, let's go.
Okay, I'm gonna try again. Paul started to implement the S1IP interface protocol, actually, which is an SN.1 protocol. It's kind of like really complicated, really badly complicated, as worse as SS7. And then he also started to implement GTP. So, because the whole idea was that we should have an MME, PGV, HGV, PCRF. But then Paul came there and said, well, look, this is kind of cool because it's pretty much the same functionality that you will get into an GGSN. And then we started to look on YateBTS and we were like, well, we need to get YateBTS to do roaming, right? Because that's what we do. We do roaming and SS7 and all kind of really cool features. So then we started to talk on how the heck are we going to solve this? And it's pretty much like we're going to get the MBTS, which is the fork of OpenBTS we are using. We're going to get the MBTS interface for data. We're just going to stick it into YateBTS. And we're going to send it to OpenSAE, which is going to behave like an SGSN. So OpenSAE now has also the SGSN, GGSN functionality, because it has all the protocols. By now, Yate supports S1IP, GTP, SMPP, diameter, of course, because we need to have the diameter support, since Yate also behaves as an HSS HLR, and a bunch of other things. And right now, the only difference is that we basically, since Yate was a telephony engine which had all these telephony protocols and data protocols and all the others, we split it into products to be able to actually manage them. But the cool thing about OpenSAE is that when we designed the actual product, we've made it to be completely redundant, so you can have one OpenSAE, but if the OpenSAE goes down and dies for some odd reason, like the connection is down, what's nice about it is that the eNodeB is going to be able to connect to the next OpenSAE. And the same happens with OpenVoLTE. If the connection goes, if the OpenVoLTE goes down, the SIP client can actually connect to the next OpenVoLTE, because that's the way the IMS VoLTE protocol is designed. And this is exactly what we kept in YateBTS when we designed the YateBTS to connect to OpenVoLTE, and OpenVoLTE behaving as an IMS toward the YateBTS. So basically, the reason why, for example, OpenVoLTE behaves as an IMS toward the YateBTS is because the YateBTS is an IMS client, which is a significant improvement for us, because it also means that, for example, YateBTS is going to be compatible with any other IMS core network. And the reason why I'm saying all that is because it also means, for example, that IMS will be compatible with another EPC core network. So one of the things that we did with that was important, including in OpenSAE, was that we wanted to be capable of getting any piece of our equipment and drop it into another network to cover one of the functionalities and still being compatible with whatever carriers already have there. Is that a comprehensive answer?
He's typing things into IRC, but he's not speaking.
No, no, I've got a boy behind me mucking around. It kind of
That's
does.
what she said.
But I've got another question now. The OpenSAE licensing model. I'm going to kill a boy in a moment. Yeah, how open is OpenSAE, and how does the licensing model work, Diana?
So the reason why OpenSAE is called OpenSAE is because it's using open standards, not because it's open source.
Aha. So what licensing model have you got built around it, or does it use?
We own the copyright of Yate. So
if we want to use it, we just pay you lots of money.
Well, that's true, but I bet you are paying far less than you've paid for your 3G network.
And you know what? I'd rather pay lots of money to you than many other people, to be perfectly honest.
Yeah, it's just sad that that didn't happen in the past.
I paid you money in the past. Don't give me that. You got paid in the end. You. Anyway, let's not go there.
You tell him. You tell him.
That's right. And you keep on kind of moving your company around to confuse our accounts department. But anyway, you know what, Diana? I'm really looking forward to seeing you and David in Barcelona. I think we're going to have a whole load of fun. And you know what? I've got Dan and Andy both on our private backchat channel saying when your dev kits come out, they want to be first in the line for your dev kits.
It's already there. I gave the link. Just send us an order.
I think what James has misunderstood is our request to get one as being first in line. What I was trying to say is, James, can you order me one, please?
All right. Well, yeah, I'll just do it. You know. Okay. That's easily done. Anybody else on here want to an OpenBTS? No, what are you calling yourself these days? A dev kit from YateBTS. That's the one. God, it's so confusing. You know, when you get to a certain age, you know, the memory starts to go, and I can't remember.
I would not know about that.
You're absolutely right. I'm noticing that. Yeah.
Right. Okay.
Also, when you get to a certain age, you just kind of freeze, and that's it now. That's all you can do.
That's all I can do.
We'll get into that in the private mature audiences section. But in the meantime, anybody have any further questions while we're public? Corrado, did you want to join in? Do you have any questions or comments on the topic here? Go ahead, test the mic.
I just hope if the microphone works, if you can hear me.
Yeah, you're actually a little bit overdriving. Can you lower the level a tiny bit? Because we're all about getting the sound good too.
Yeah. Is that better?
Yeah. Good.
Okay, great. Now, what I was wondering if what is the relationship between that project and what I've seen quite a number of years ago, femtocells. So, if there's any resemblance.
Femtocells?
Exactly.
Yeah.
Okay, so YateBTS, it's not a femtocell. Okay?
Yeah.
First of all, because a femtocell, it's something that doesn't support handover. YateBTS, it's a base station that allows you to build a full-blown mobile network. Femtocell, it's some sort of a weird thingy that you get to put into your house, and they make sure you don't share it with anyone else. So we are not talking here about some sort of a small things that you install in-house. We're talking here about real mobile networks.
Okay, so we are practically building another MNO, another mobile provider.
Absolutely, we are talking about MNOs here.
Yeah,
with full roaming support and billing and everything else, yeah.
That's fantastic, especially for suppliers and providers of telephony like we are, to be out of the grabby hands of big players and be ready to deploy a local, probably, supplier.
All you have to do, Corrado, is find some spectrum from somewhere. And then you're good to go.
Yep. Well, possibly.
That's the tricky bit.
Yeah, especially in the UK, Ofcom is not that much helpful.
No, they're very helpful. They're lovely, lovely people. Really.
Ofcom will give you spectrum if you have enough money.
Exactly.
I mean, look, about a few years ago, weren't there like a dozen nationwide DCS 1800 licenses?
Absolutely, absolutely. There were exactly a dozen, and the lowest bidder for that spectrum paid a mere £50,000 for a UK-wide license. Absolutely nothing. But having said that, the same spectrum, which is the top end of the DCS 1800 band, is license-free in other countries like the Netherlands, for example. So if you're in the Netherlands, you want to run low-power GSM, you can do so on license-free spectrum. The drawback is it's only, 20 channels wide, so it's enough to do low-power 2G, but not enough to do, certainly not enough to do 3G or even any kind of meaningful LTE. So, yeah, we use it too.
So let me ask you this, James. Do you actually have such a license?
I'm not going to give you the answer to that live on air, am I?
No, he's not. I just wanted to zoom back for a second and say that for those of us who are older, I guess I could maybe include James, but he's maybe the only one here. Zooming back for a second, if you look at one of the exciting things about this kind of technology, and what David's been doing since I met him a couple of years ago, in the early days of, say, radio when I was a kid, when James was a kid, there was nothing you could do except a little bit of ham radio and what was it, in the United States, part 15, I think, part 17, part 19, I can't remember which was 100 milliwatt, so you could experiment, and the internet did to publishing what this kind of thing is doing to radio and telephony. In the middle years of, say, 1980, there was a monopoly in the United States, and most European countries had monopolies too, state-run, right, for telephony, and things like Asterisk and Yate and Free Switch and all of the variations thereof turn things into a much more level playing field as far as, I know I'm confusing all kinds of different technologies, but bear with me. What I'm saying is that there was a time when you could do absolutely nothing, And now we're in a time, and we have been for 20 years, where you can do a lot of things on some of these technologies. And what bringing it to now, the present, and what we're talking about with YateBTS is that there are many things that can be done for a very modest budget that in other times would have cost millions. Does that make any sense to anybody? Because I hope that's the way I see it. That's the way I see it.
Yeah.
Is that these folks are empowering whoever has like the $20. I'm exaggerating, but it's not like you need $100 million to bid on that spectrum anymore. It's a different game, and that can only be good as far as I'm concerned.
Yeah, absolutely right. I'll give you an example. You can go out and you can buy, I don't know, a $30 Huawei 2G, 3G dongle, stuff that into your Asterisk box using mod, what's the channel driver called? Anyway, the channel driver. And what's it called, Dan?
Chan something. Chan Charlie.
Chandongle, isn't it? Chandongle, of course it is.
Yes,
Chandongle, yeah, that's the one. And immediately you've got a 2G, 3G radio link, which can do voice and SMS plugged into your address box, and all for $30 new. You can get them cheaper off eBay. And that is just incredible amounts of power for next to no money. And it's very, very exciting.
I will say that one of my friends used to say something that his teacher said: let's make a new quality out of the quantity. I believe that all those advantages are actually there because the computers have become so powerful.
Yeah, indeed. Another example, just look at the things you can do with a tiny little 25 pound Raspberry Pi. People running Asterisk on that, and I've even seen somebody running an HLR and a mobile network on a Raspberry Pi. Absolutely stunningly amazing, really, when you think about it.
These are exciting.
That's absolutely true.
These are exciting times. I think that's the key phrase of what we're talking about here, is that these are exciting times. It's very much raising the limits of what can be done. People like David, Paul, and Diana, thank you very much. We're going to, unless Carl or someone else has other questions, we should probably take it out here. So, anyone, did we leave anything out? Do you have questions? James, Carl?
Yeah. Well, before we go, can I say something nice? Sorry.
Yes, no, I just wanted to say one thing very important, is that I wanted to comment on Jerry's goatee, which looks great. Okay, go ahead.
Yeah, I wanted to say something really nice about Yate before Diana. There's all kinds of things, coming back on the back channel thing now. Well, I was going to say something nice about Yate, but perhaps I won't now. Yate, brilliant bit of software, and yeah, I'm not going to say it now.
All right. Well, you can say it at NWC or whatever it is.
Yeah, there was somebody else who wanted to comment there. Was it David? The other David? No. I doubled with somebody rather rudely.
No, that was me. I was trying to get in the plug for Jerry's beard.
Oh, Jerry's beard is almost as impressive as yours.
Well, mine hasn't been shaved yet.
You know who you look like, Randy?
Tell me.
You look like a bit like David Beckham.
Okay.
I think.
Is that Victoria's husband? Victoria's
kind of like a slightly older version of David Beckham.
Yeah, well, he's going to have to.
Don't you think?
I was actually going for the guy from Virgin. What's his name?
Okay, guys.
No.
All right. Anyway, I think we're degrading
that's
into.
That's enough to do Diana in.
Yeah. Anyway, the important thing is, though, that you can go to YateBTS.com. You can probably contact everyone here everyone here from YateBTS, David, Paul, Diana, by going there. I'm sure there's a contact thing. If there isn't, they'll build one between now and 20 minutes from now. And check that out. Really appreciate it. This is what VUC is about, as far as I'm concerned, having people like this on. So I'm proud to have you. Diana, you know where to reach us if you have new announcements, and we're always pleased to have you guys.
Thank you very much, Randy, and I will say that, yes, we're going to have a huge amount of announcements in the next 6 months.
In that case, we'll have a huge amount of you back here in the next 6 months, and that'll be great. Okay?
All right. Thank you very much.
Thank you, guys, everybody. Thanks for what you're doing for the state of the art, too. We're going to stop the broadcast. We'll go to the mature audiences only, and, of course, you're all welcome to stay. Thanks.
Are we mature?